This is a video from section 11.2 in my Calculus 2 class. The directions say to determine whether the given series converges or diverges. If it converges, find the sum. In example 1, we have 1/3 plus 1/6 plus 1/9 plus 1/12 plus 1/15, etc. So notice how the denominators are all multiples of 3. So why do I care? So I can write this as 1 over 3 times 1 plus 1 over 3 times 2 plus 1 over 3 times 3 plus 1 over 3 times 4 plus 1 over 3 times 5 plus ... And so this can be rewritten as follows. It's the summation from n equal 1 to infinity of 1 over 3 times n. Okay? Now, let's just start here. The summation from n equal 1 to infinity of 1 over n diverges. And this is by, you can say p-series. This is harmonic series. You can say it diverges by the integral test even. Okay? So that's a harmonic series. Now, that implies the summation from n equal 1 to infinity of 1 over 3 times n also diverges. And I'm going to say a constant multiple of a divergent series must diverge, right? I hope that's okay. And so what that implies is the following. 1/3 plus 1/6 plus 1/9 plus also diverges. So in other words, if I wrote that sum in expanded form, I get that. And that's how we do example 1. Let's take a look at example 2. So in example 2, we have the following. So suppose we have the summation from n equal 1 to infinity of 1 over 4 plus e to the negative n. But that's the summation from n equal 1 to infinity of 1 over 4 plus 1 over e to the n. Test for divergence right off the get-go. So I'm going to look at the limit as n goes to infinity of 1 over 4 plus e to the negative n. But that's the limit as n goes to infinity of 1 over 4 plus 1 over e to the n. But as n gets large, what does 1 over n approach? And I claim that goes to 0. And so that's 1 over 4 plus 0, which is 1 over 4, and that doesn't equal 0. So right off the get-go, we can say that the summation from n equal 1 to infinity of 1 over 4 plus e to the negative n diverges, right? By test for divergence. And just like that, we've done example 2. Let's take a look at example 3. So, in example 3, we have the following. Okay, so we're going to go ahead and do this. Suppose we have the summation from k equals 0 up to infinity of square root of 2 to the negative k. Okay? But if you don't mind, I'm going to write this as the summation from k equals 0 to infinity of 1 over square root of 2 raised to the k. But that's the summation from k equals 0 to infinity of 1 over the square root of 2 to the k power. Okay, now, a couple of comments. Can we agree this looks like a geometric series? Here, let me back up a step. This series converges by the geometric series test. And we're going to get the absolute value of r is 1 over square root of 2, and that's less than 1. Okay? Now, the question is, what does this equal? Now, the summation from n equals 0 to infinity of ar to the n is a over 1 minus r. So that's the actual sum of the series. Okay? So let's get back to this. So we have the summation from k equals 0 to infinity of 1 over square root of 2 to the k. Now, a, here, let me write that underneath. So a is 1. The absolute value of r is 1 over square root of 2. And so this is a over 1 minus r. So wherever I see an a, I'm going to plug 1 in its place. And then I'm going to divide by 1 minus 1 over root 2. So I'm going to multiply the numerator and denominator by square root of 2 divided by square root of 2. So therefore, the summation from k equals 0 to infinity of 1 over square root of 2 to the k is square root of 2 divided by, okay, that's square root of 2 times 1, and then square root of 2 times 1 is square root of 2, and then 1 over square root of 2 times square root of 2 is minus 1. That's my a over 1 minus r. In simplified form, by the way. So that right there is example 3. Let's take a look at example 4. So it says find the values of x for which the series converges. And then the next step is find the sum of the series for those values of x. And that's going to lead really nicely into power series. Okay? This is really nice. Now, let's take a look at A. So, suppose I had the summation from n equal 1 to infinity of negative 5 to the n, x to the n. But that's the summation from n equal 1 to infinity of, we'll call it negative 5x all raised to the n. Okay? Is that okay? Now, here's the deal. This series converges. You want to think geometric series the whole time. When the absolute value of r is the absolute value of negative 5x. Now, what is the absolute value of negative 5? The absolute value of negative 5 is 5. So this is 5 times the absolute value of x is less than 1. So can I divide both sides by 5? And the answer is, of course. So the absolute value of x is less than 1/5. And so what that tells me is that negative 1/5 is less than x, which is less than 1/5. So those are the values of x that make that series converge. Think geometric series. Now, what we need to do is find the actual sum of that series. That's the next challenge. So I'm going to start here at the summation from n equal 1 to infinity of negative 5x to the n. But that's the summation from n equal 1 to infinity of negative 5x, that quantity, times negative 5x to the n minus 1. Okay, now A is negative 5x, right? And R, now let's think about R for a second, right? R is negative 5x, right? So remember, this is A over 1 minus R. But A is negative 5x. Remember, x is wedged. Here, let me write this down here. X is wedged between negative 1/5 and 1/5. Okay? So I'm going to divide by 1 minus negative 5x. And so, therefore, the summation from n equal 1 to infinity of negative 5x to the n is negative 5x divided by 1 plus 5x. And that's how you do part A. Let's take a look at part B. Now, in part B, we can do this one. Now, suppose we have the summation from n equals 0 to infinity of 2 to the n divided by x to the n. But that's the summation from n equals 0 to infinity of 2 over x, all raised to the n. Now, if you don't mind, I'm going to write this as the summation from n equals 0 to infinity of. So this is 2 over x. I'm going to pick off a 2 over x, and I'm going to multiply by 2 over x to the n minus. Oh, take that back. The lower limit is 0, so this is actually okay up here. And that what gave it away is the lower limit of 0. Okay? Now, this series, think geometric series. This series converges when the absolute value of r, which is the absolute value of 2 over x, right, is less than 1. So now, therefore, we can say 2 over the absolute value of x is less than 1, which implies the absolute value of x is greater than 2, right? Now, what does that say? You got two choices. You got x is greater than 2 or x is less than negative 2. That's it. Okay? Now, so that's when the series converges. So the question is, what does it converge to? So we're going to come back to this. Now, my r is 2 over x, right? That's r. And my a is 1. So I get a over 1 minus r. But that's 1 over 1 minus 2 over x. I'm going to multiply the numerator and denominator by x. And my total sum is x over. Now, x times 1 is x. And then 2 over x times x is 2. And that's how we find the actual sum of the series. Okay. So that was part B. So when x is greater than 2 or x is less than negative 2, series converges. And once you know the series converges, we can figure out what it converges to. And that's what this page is for. Okay, that'll do it for this video for section 11.2. And we looked at 4 problems and 2 parts on problem number 4. So, okay. All right, thank you.